Hey everybody. So I'm just gonna do a couple of examples of the classwork that we did. So one thing that I really want to stress about this is that constants and variables, you can kind of treat them independently, separately. You can deal with them separately and then put them back together at the end. So for example, for number 1, 3a squared cubed. All right. So right off the bat, the first thing I want to do is make sure that there's nothing left to do inside the parentheses. In this case, there's nothing left to do. Then what I'm going to do is I'm going to split them up, but remember that there's a cubed right there, right? So both of these are going to be to the power of 3. So this becomes 3 to the power of 3, and then a to the 2 to the power of 3, okay? I split them up. Oh, that's a 2. That should be a 3. There we go. Good enough. So here, 3 to the 3, that comes out to 27. And then here, a to the 2 to the 3. Remember, when you have an exponent to an exponent, you're supposed to multiply. So that's a to the 2 times 3. That's 27. A to the 6th. Okay, I did them separately, and I put them back together at the end. Let's try something a little bit harder, like number 13. So again, with number 13, I know I did this in class, but maybe if I explain it a little better, it'll be a little bit easier. So again, I'm going to see what else I can do, right? So these are multiplying. So I'm going to multiply the constants together, and then I'm going to multiply the variables together. So right now, my constants are 3 and 2. So I'm going to multiply them together first, inside the parenthesis. This is all happening inside. So that becomes a 6. And then now I'm going to do my variables. So x squared times x squared is going to be x to the 2 plus 2. Remember, if you're multiplying, same base, you just add the variables. And that's all still squared. So this comes out to 6x to the 4th squared. Right? Looks a lot like our previous problem. We're going to split it up. So I have 6 squared and x to the 4th squared. 6 squared is 36. X to the 4 to the 2 is x to the 4 times 2. So my final answer is going to be 36 x to the 8th. Okay, we'll do another one. Let's try number 16. So we had 3x times 2x squared. Again, I'm just going to deal with my constants first. So 3 times 2, because it's multiplication. So I'm just going to do 3 times 2, which is 6. And then I'm going to do my variables, which is x times x, which is x squared squared. And then it's all to the 2. Again, looks a lot like the other things we've been doing. I'm going to split them up. So I have 6 squared, and then I have x squared squared. So 6 to the 2 is 36. X to the 2 to the 2 is x to the 2 times 2. So my final answer is going to be 36x to the 4th. All right. If you need further examples, bring them to class. Again, I'm only grading on your effort for now. Don't worry too much about your classwork not being 100% accurate. We will iron those out before the end of the unit. Okay? So as long as you're putting the effort in, you're getting the grade. So I'll do one more, just to be sure. Okay. Where was I? Let's try this one, number 17. So we have 4 x to the fourth times x to the fourth to the 3. In this case, there's no other constant, so we kind of just bring down the 4. But then we can do x to the fourth times x to the fourth, which we're supposed to add. So that's x to the 4 plus 4, all to the 3. So that becomes 4x to the 8th to the 3. Then we're going to split those up. So this becomes 4 to the 3 and x to the 8 to the 3. Remember, when we split them up, we still have this parenthesis and to the 3 on the outside, so we can't forget that those exist. They still apply to our numbers even though we split them up. So 4 to the 3 is like 64, I think. It's 64. And then x to the 8 to the 3, that would be x to the 8 times 3. Right? So that's 64, and then 8 times 3 is 24, so x to the 24. Right? So now that we have that out of the way, I'm going to go over scientific notation. So, scientific notation is a mathematician's way of writing either really, really big or really, really small numbers. Okay? For example, if I told you to do a problem, if I told you that you could write this number, oops, in a much easier way, would you take it? Well, I would, and a lot of scientists would. Writing this number over and over and over again will take a lot of time that nobody really wants to do. So, the way that we do it is something called scientific notation. What we have here is called standard notation. So when they talk about standard notation, they just mean the standard way of writing it, the normal way of writing it. Okay? So that's one of your vocab. Standard notation just means the normal way of writing things. And so now we have scientific notation. So there's some rules to scientific notation. So let me write this: scientific notation rules. Okay. Number one, first, you put a decimal after the first non-zero. Okay. So what that means is here, the first non-zero is going to be, let me use red, 5, because you always want to read from the left, right? So 5 is my first non-zero, so the decimal goes here. So if I were to write that, it would go, if I can get a pencil, great. So 5.675, and then I don't need the rest of the zeros, right? If it's after a decimal point, those extra zeros just are kind of pointless. They don't help you understand the value. So all these zeros, gone. Next. Number 2. Put a times 10 next to your number. Okay, simple enough. So if I were to rewrite it, it would go 5.675 times 10. Okay. And then step 3. If I can get, there we go. Step 3 is to put an exponent on the 10 depending on which direction the decimal had to go. Now, this part is probably the most confusing part and will take a little bit of practice. Before we start, I'm just going to say that if you had to move to the left, it's +1. If you had to move to the right, it's -1. Now, here in this original standard notation, the original position of the decimal was back here. It was at the very end of the number. And we moved that decimal to make our scientific notation. So we went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We went 12 places to the left. That means we went positive 12 exponent. So the way I would write that is 5.675 times 10 to the positive 12. Okay? We'll do another example, but remember to bring questions if you're not really understanding this to class. All right? So let's see here. Let's try another problem. Let me get rid of this. Okay. So here we go. Let's say we want to do 200, let's try 0.95. The minnow, right? 0.95. So first step, we're gonna put a decimal after the first non-zero. So here the first non-zero is 9. That's our first non-zero. So 9.5. Okay. You don't need to put the 0 in front for whole numbers. I mean, you can if you want to. It doesn't really make a difference. Next, we're going to put a times 10 next to the number. So 9.5 times 10. And then we're going to put an exponent on the 10, depending on which direction we had to go. So if the original decimal, well, let's see. Let me rewrite this. If the original decimal was 0.95, I had to move this decimal one place to the right to get this. So since I moved 1 to the right, I'm going to minus 1. So I have 9.5 times 10 to the negative 1. Okay. I'll do one more example. So let's say we got 0.0783. So let's try that. 0.0783. Okay. So again, put a decimal after the first non-zero. So the first non-zero here is 7. Starting from the left, it's 7. So 7.83. Put a times 10 next to it. So 7.83 times 10. And then put an exponent on the 10 depending on which direction you went. So here I went 2 places because it's now here, right? I went 2 places to the right, so that's 7.83 times 10 to the negative 2. Okay? If you have any other questions about this, bring it to class. So now that we've learned how to create scientific notation, now we're going to learn how to use it. So one of the things that we're going to learn today is addition and subtraction. We'll go over multiplication and division on Thursday. I'll teach you that skill on Thursday, but for now what I want you to be able to do is addition and subtraction of the scientific notation. Actually, maybe I'll teach you multiplication and division in this video as well, and then just review it. Should be fine. Yeah. So one thing that you need to know is that addition and subtraction have the same rules. So when you're dealing with addition of scientific notation or subtraction of scientific notation, you're doing the same rules. Multiplication and division also have the same rules. So you only have to learn 2 sets of rules. So first, let's say we wanted, I don't know, what is this? Let's say we wanted to add these two, right? So we had 3.1 times 10 to the 8th added to 3.38 times 10 to the 7th. Okay, so let's go over the steps. Step 1. Let me change the color. So step 1. What you need to do is make sure the power of 10, so the exponent on 10, is the same. If they're not the same, you need to make them the same. So right here, we have 3.1 times 10 to the 8 and 3.38 times 10 to the 7. They're not the same. Now the way we're going to do this is remember that little directional thing that we had where we said left, let's do it this way. Left is +1 and right is -1. So it's your choice. You can either turn this into a 7 or you can turn this into an 8. It really doesn't matter in the grand scheme of things. It's really up to you. Personally, I like to make numbers bigger as opposed to smaller. So the decimal was originally here. And because I want to make this an 8, I want to +1 to it, I have to move left 1. So right now, I have 3.1 times 10 to the 8th plus 3.38. Oh, no, wait, that's not right. I moved the decimal already. So 0.338 times 10 to the 8th. Yeah, I moved the decimal and I changed that. Step 2, add the front parts. Okay, in this case, I'm going to tell you what the front part is called. It's called the multiplier. So the front part right here, this is called the multiplier. So when I'm talking about the multiplier, this is what I'm talking about. So you're going to add the front part, or also known as the multiplier. So we have 3.1 plus 0.338. Together you get 3.438. And then the last one is just put the 10 and same exponent at the end. So in this case, we put times 10, and the exponent that we used was 8. We made them both 8, and that's the final answer. Now, be very careful. Sometimes, depending on what you choose, this might not be in scientific notation. The number one way to know if your answer is done and it's in scientific notation is the decimal after the first non-zero? If yes, yeah. If not, you need to change it. And I'll show you how that's done. Take note of this if you need to. I'm going to change it. I'm going to change the problem we're doing. So feel free to pause this, but I'm going to take this out right now. Oops. So the rules are exactly the same. I wrote add here, but really you can put it as subtract also. It works the same. So what if I did 1.1 times 10 to the 8. Actually, I'll move this up here. And there we go. 1.1 times 10 to the 8 minus 3.38 times 10 to the 7. Okay. So the way that works is, let's say I move it downwards this time. So I want to turn this 8 into a 7. If I want a -1, I have to move the decimal 1 place to the right. So it'll go there. So now I have 11 times 10 to the 7th, because I changed this by moving the decimal over, minus 3.38 times 10 to the 7th. So I did the first part. I made sure that the exponents were the same. I subtract the front part. It says add, but remember, add and subtract have the same rules, so just pretend it's subtract. So we have 11 minus 3.38. So it looks like we have to borrow. So that becomes 0. Carry the 1, that becomes a 9, and that becomes a 10. 10 minus 8 is 2. 9 minus 3 is 6. Bring down the decimal. 0 minus 3 is, well, that can't happen, so we got to borrow. 10 minus 3 is 7. So the answer here is 7.62 times 10 to the 7th. Wow, okay. I was hoping that that would come out to something different. But let's just say that that's what we got. And then I'll give you example, multiplication and division, I'll show you an example. But see how addition and subtraction are the same? I will go over more of these during class time, but this is just kind of to dip your toes in the water, kind of show you what this is about. Please come to class with these notes, with these steps. I'm just going to assume that you know them. All right? So for multiplication division, I've decided that I'm going to do it this video. Let's say that we have, awesome, let's move this over. Let's say that we have these two numbers. So these two numbers are 2.025 times 10 to the 14th, and then this is 225 million, so 225 million. Okay. First off, I'm going to turn this into scientific notation because we're learning scientific notation. So I'm going to put the decimal after the first non-zero. So 2.25 times 10 to the, what is that? Decimal is originally here. 1, 2, 3, 4, 5, 6, 7, 8. So I moved 8 to the left, which means 10 to the 8. Okay, so those are my two numbers now. If I were to divide them, so here I have 2.025 times 10 to the 14th divided by 2.25 times 10 to the 8. Okay, the steps are very much more straightforward. Step 1, multiply or divide the multiplier. So this would, I would pretty much just box it off like this. So 2.025 divided by 2.25, what is that? By the way, feel free to use a calculator for these. I'm more concerned with your ability to remember the steps for this than I'm concerned for your calculations. So 2.025 divided by 2.25 comes out to 0.9. And then your step 2 is going to be multiply or divide the 10 with the exponent. So I'm going to do this back part then. So 10 to the 14 divided by 10 to the 8, as now you should be pretty good at this. So the answer to that is 10 to the 6th. Multiply just goes straight down. So that's my final answer. My final answer is 0.9 times 10 to the 6th. Well, I shouldn't say final answer. That's just my answer that I got. This is not in scientific notation. The decimal is not after the first non-zero. I want it here. So if I wanted 9.0, if I wanted to move this over 1 to the right, I have to minus 1. So times 10 to the 5th. All right. So here's a couple examples. Again, we're going to be going over this again in class, but please have these notes and have these steps ready for when I do examples with you. Okay. Have a good day, and I'll see you on Thursday.